Physics Part 236. We've got the section summary here. Insulators may be charged by friction. Like charges repel, unlike charges attract each other. When charged objects are placed near conductors, they cause redistribution of charge in the conductor, thereby inducing charges. The force between 2 point charges is proportional to the product of the charges and inversely proportional to the square of the distance between them. This is Coulomb's law. F is equal to Q1 into Q2 over 4 pi E0 R square. E0 is the permittivity of free space. Its value is 8.85 into 10 raised to minus 12 C square Newton per meter. Fm. An electric field is a region of space where a stationary charge experiences a force. Electric field strength is the force per unit positive charge. E is equal to F over Q. The electric field between parallel plates is uniform. The field strength is given by E is equal to V over D. The electric field strength at a point in the field of an isolated point charge is given by E is equal to Q over Q over 4 pi E0 R square. The electric potential at point in an electric field is the work done in beginning unit positive charge from infinity to the point. The potential at a point in the field of an isolated point charge is given by V is equal to Q over 4 pi E0R. We've got few section questions for you. A glass rod rubbed with silk becomes positively charged. Explain what has happened to the glass. Explain also why the charged rod is able to attract small pieces of paper. Number 2, explain what is meant by an electric field. Sketch an electric field pattern between two negative charged particles. Sketch the electric field pattern between a positive charge and a negatively charged flat metal plate. Number 3. In a simplified model, a uranium nucleus is a sphere of radius 8.0 into 10 raised to 15 per meter. The nucleus contains 92 protons, rather more neutrons. The charge on the proton is 1.6 into 10 raised to minus 19 C. It can be assumed that the charge of those protons acts as if it were all concentrated at the center of the nucleus. The nucleus releases an theta particle containing 2 protons and 2 neutrons at the surface of the nucleus. Calculate the electric field strength at the surface of the nucleus before emission of the alpha particle. Calculate the electric force on the alpha particle at the surface of the nucleus. Calculate the electric potential at the surface of the nucleus. Calculate the electric potential energy of the alpha particle when it is at the surface of the nucleus. Our next section is capacitance. Capacitance. At the end of this section, you should be able to define capacitance and the farad. You should be able to recall and solve the problems using C is equal to Q over V. You should be able to deduce from the area under a potential charge graph the equation of W is equal to 1 over 2 QV Hence W is equal to 1 over 2 CV square. You should be able to derive using the formula C is equal to Q over V. Conservation of charge and the addition of PDS formulae for capacitors in series and in parallel. You should be able to solve the problems using formulae for capacitors in series and in parallel. You should be able to show an understanding of the function of the capacitors in simple circuits.